All right, so it says, Jada and Noah counted the number of steps they took to walk a distance. They walked the same distance. So Jada took 8 steps to walk this distance and Noah took 10 steps. That means that Jada took bigger steps and Noah had to use more steps to get there. So his steps were smaller. If you look over here in the equation, we're going to talk about this equation in a second, but I think part A is going to be a little bit easier for you, so we're going to start there. So they found that when Noah took 15 steps, Jada took 12. All right, so what we can do is this says create a table. A table would be really good for this because it kind of like starts giving you something. Right now it's just a bunch of words. Okay, so we have Jada and we have Noah. Okay, so it says Jada took 8 steps, Noah took 10, then Noah took 15 steps, and Jada took 12. Okay, so we've got to figure out how this table is changing. Okay, how many more steps do they take? And they're going to keep taking that amount more. All right, so if we went from 10 to 15, so that means they went up by 5 steps. So if we continue our table, and you can do it for however long you want. It says at least 3 pairs, so you don't have to do too much, but you can do as much as you want. So then it's going to keep going up by 5. That's the only thing we know, that his distance changed by 5. So you can keep doing that for as long as you want. All right, so 10 to 15, 15 to 20, 20 to 25, 30, 35, and 40. All right, so then Jada went from 8 steps to 12 steps. So she increased by 4 steps. So then you're going to add 4 each time. And sorry, I just messed up my coloring up here. All right. So 12 plus 4 is 16. Plus 4 is 20. Plus 4 is 24. Plus 4 is 28. Plus 4 is 32. I meant for these to be purple. Okay, so now let's go back to this equation part. So it says let X represent the number of steps Jada took. So you know X is Jada. This part we really probably didn't fully do a problem like this. You have enough information kind of to get this idea, but I don't think many of you will do this on your own. So let's go and do it. And let Y represent Noah. So the first thing that we need to do is I want to take out X and Y so you get an idea of what this question is talking about. So it says X is Jada. So that means 5/4 of Jada is equal to Y, Noah. So Noah equals 5 out of 4 of Jada. So most of you don't like fractions, okay? So let's go ahead and instead of 5/4, we know that's going to be bigger than 1, but let's get a value for that. So 5 divided by 4, you know fractions mean divide. So that's going to be 1.25. So we have Noah equals 1.25 of Jada. So that means that Noah's steps are equal to all of Jada's steps plus 25% more or a little bit more. And that's what this looks like. Jada took 8, so Noah took 8 and a little bit more. Jada took 12, so Noah took 12 plus a few more. So that's all that this is saying, okay? And if you notice, the 5/4 is the difference, or it's the rate of change. So we have Noah's steps are changing by 5, and Jada's steps are changing by 4. So that's where they get the slope there, which is your rate of change. And that'll make a little bit more sense once we get to the back. All right, so let's go ahead and move to the back. I'm going to go ahead and copy this table down. I think maybe I'll just do it over here. So Jada, so I can have it. So Jada and, what's his name? Jada and Noah. And then we know Jada is X and Noah is Y. So we can go ahead and put an X and a Y here. And then what do we start with? 8 and 10. So 8 and 10. So this was easier. So 10, 15, 20. And it doesn't really matter how far you go. You know, these are increasing by 5. These are increasing by 4. So what is this? 12, 16, 20, 24, 28, 32. Okay, so what it says graph the relationship and label the axis. Well, since we know that X is Jada, we're going to go ahead and label that. So X is Jada and Y is Noah. You don't have to put Jada, excuse me. You don't have to put Jada and Noah, but it may help you. Okay, so they're not numbered. We got to number it, but we got to remember that we got to get this information on here. So I think I'm going to number my Jadas by 2 and my Noahs by 5 because these are, actually I could probably number these by 4. That's what I'm going to do. So I'm going to start with 0. You can number them by 1s, but the only problem is you're probably not going to be able to get to 12, 16, and 20. Okay, so you want to make sure you have some numbers on your graph. You could label everything by 2s, but the problem is you're not going to ever get to 5. It's going to be 2, 4, 6. You're going to jump over your 5. So I'm going to label my X and my Y axis differently. So Jada, I'm going to go ahead and number by 4s. So 4, 8, 12, 16, 20, 24, 28, 32, and I'm just doing multiples of 4. 36, 40, 44, 40, let's see, 6, 8, 52. All right, and then I'm going to label my Noahs by 5, my Y's by 5 because they're counting by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Sorry, you can't see. 65. Okay, so then it says that we just need to label the information. So you're matching. We've done this 1,000 times in class. You're just matching. So our first point is 8 and 10. So 8 and 10. Our next point, and you're going to check them off as you go, is 12 Jada and 15 Noah. So 12 and 15. 16 and 20. 20 and 25. 24 and 30. And look, you can keep going because you know it's going to be the same each time. Okay. If they took half the distance, then you know it would be 4 and 5, and they start at 0 and 0. So you have a straight proportional relationship because proportional, remember, means straight line going through 0. Okay, so how can you calculate the constant of proportionality in each representation? Okay, so the constant of proportionality is your Y's over your X's when you divide these ratios, or these rates, I guess. And so you get 10 over 8, and then you also, and I'm just going to put commas, 15 over 12, 20 over 16, 25 over 20, 30 over 24, 35 over 28. Okay, so those are all your Y's of the numbers that you get. Okay, so constant means stays the same. All right, so in proportional are two rates or two ratios or two fractions that are equivalent to each other. So we know these are all fractions. When you write them like this, they're all fractions, but they all look different. So what we are going to do is we're going to divide. And so we're going to divide them. 10, or you could reduce them. It's up to you. 10 divided by 8 is 1.25. And then you're going to keep doing it. 15 divided by 12. Oh, what do you know? 1.25. And then 20 divided by 16. Oh, what do you know? 1.25. And if you keep doing it, you are going to get that constant rate of 1.25. Okay? Now, you can also simplify your fractions. All right, so 10 and 8 both have 2 in common. So divide by 2, divide by 2. So 10 over 8 turns into 5 over 4. And if we divide 5 divided by 4, voila, it's also equal to 1.25. So 15 and 12 can be divisible by 3. 15 divided by 3 is 5. 12 divided by 3 is 4. So they look different because your values are increasing every time, but they're increasing if you go back to your table. Noah is increasing by 5, while Jada is increasing by 4. And that is your constant of proportionality. That's what's constant about this graph. Okay, and if we count the way that we went up, so if you go up, rise over run, remember, it looks like 1 over 1, but we're not counting by 1. So you're going up by 5. You're going over by 4. And so your rise over your run, or your slope of this line, is also 5 over 4. They're all related. All right, so it says, explain how you can tell the equation, description, graph, and table all represent the same situation. Well, you can explain these multiple ways. Now that we've done this, I think you can explain this part on your own, using your own words. But we took Jada and Noah's information, we put it into a table. We took the table, created a graph. The graph and the and the table all represent the equation. So you're going to give me some little piece there. Okay. So now I think it's just some practice problems about that. So here are 2 ways to represent a situation. I can't read. The Origami Club is doing a car wash fundraiser to raise money for a trip. They charge the same price for every car. After 11 cars, they raised a total of $93.50. After 23 cars, they raised $195.50. It says write an equation that represents the situation. Use C to represent the number of cars and M to represent the total amount raised. So if you want to continue to do what we did before, you can figure out the rate of change. All right, so if we went up by, let's see, 10, 11, 12 cars, the cost went up by, you could do this in your head or you can subtract to find the difference. 195.50 minus 93.50. Increased by $102. So you know that 12 cars cost $102. You also know that 11 cars cost $93.50. You know 23 cars cost $195.50. So if you want to, you can divide all of that. So $93.50 divided by 11. That was 8.5. That is $8.50. Okay, let's see if it keeps going. So 195.50 divided by 23 cars. 195.50 divided by 23 cars. Oh, 8.5. And they said they cost the same, so you should be getting the same number. Now let's see if it works this way for this one. So we increased by $102. That increased by $12. Oh, what do you know? 8.5 or $8.50. So that means that it's $8.50 per car to get your car washed, which I feel like that's pretty fair. So it says write an equation to represent, okay, so C represents the number of cars and M is the total dollars raised. So the money equals something times the cars. Well, how much did each car cost? $8.50. So $8.50 per car equals the total amount of money. Okay, so let's kind of do an example. So if you were to do $8.50 times 1, that would be $8.50. If you wash one car and charge them $8.50, you would have only earned $8.50. If you wash 2 cars, $8.50 times 2 would be $17. Okay, so that's what this equation represents. Okay, so next it says graph the situation. This is going to be a little bit of estimating because you are talking about money, which you're talking about 50 cents. So let's see here. So we're going to let X be the number of, so they label it here. So cars and money. you could count however you want. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. You could count by ones. That's perfectly fine. Your money, though, you're going to have to do a little bit different on that. So let's go ahead. So you can count these by ones. That's fine. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. And then here, we're going to do a little break, which we've done before. And I'm going to go up. I think I'm going to start at 90. And then maybe count by, geez, this is aggravating. Maybe 10. So 100, 110, 120, 130, 140, 150, 160, 170, 180. That's not going to work. I guess I got to count by 20. So 110. Sorry. So 90, 110, 130, 150, 170, 190, 210, 230, 250, 270. It's probably going to be the best way to do it. You could number by twos here if you wanted to. All right, so we need 11 cars. So we know 0, 0, because 0 cars would get you 0 money. 11 cars is 93.50, so we're going to go up to 90. We're going to go literally right past that because that little box right there for my graph represents 20. And then we're going to go up to 23 cars, and we're going to go to 195. That's 170, 190, 195 would once again be right across from it. This should be a straight line, but unfortunately, because of the break in our graph and stuff, it's wonky. So do your best you can on this graph. It is not my favorite by far. All right, so it says, how can you calculate the constant proportionality? Remember last time, you have to take your data and you're going to divide them to see what's constant about them. So the first number was 93.50 divided by 11 cars. Then you had $195.50 divided by 23 cars. And then we also found the rate of change, which was $102.12 cars. And when you divided that, we've already done this. You can do it again if you want, but you get 8.5 each time, which means $8.50 per car. And then once again, how can you tell the equation, description, graph, and table all represent the same thing? Well, we use the table to get the constant proportionality, which is the $8.50 per car. And then if you had, this table is junk for this graph. This is really hard for you to compare the table to the here. If this was a better graph, you could see the $8.50 per car better, but these numbers you have to estimate so much and they're so big that it's not helpful. But you used all of this information to graph, which gave you these same numbers. So you go ahead and answer that part. All right, this is going to be the last one we do for this little video because it's getting close. I'm trying to keep my videos under 30 minutes because they upload much faster that way. So it says 10 people can dig 5 holes in 3 hours. If N people, that means the number that we don't know. So if some number of people dig all the same rate, dig M holes in D hours. Lord have mercy. All right, so we know 10 people. So let's create a table. So we got people, and we have hours, holes and hours. I don't know what's going on here. Hold on. All right, so 10 people can dig 5 holes in 3 hours. If N people dig at the same rate, dig M holes in D hours, is N proportional to M when D equals 3? Look, I don't want y'all to worry about this here. Do a big old X on that. Y'all don't worry about that one. That's too much for us to do, too much for y'all to do at home by yourself. If you tried it, thank you, you're amazing. If you didn't, then you can just X it out because that's just too much for us to do right now when I'm not in front of you. All right, so you can read through this if you would like. We are actually here. We'll do this last problem together if we need to do anything. Nope. And all of this says, this is just like teaching you something real quick. All right, so there's nothing really to do on this page. So next video, we're going to start with Unit 3, Lesson 3, practice problems. So I'm going to stop this for now and upload it.